Hi, Jack Pine here at the kitchen table talking about how stackers can avoid being taken in by fakes and counterfeits. When the spot price rises, it becomes much more profitable to fake the real thing. In a series of videos, I hope to give the average person a way to fight back and prevent being taken advantage of by the crooks. There are many tests you can perform to find out whether what you are buying is genuine. One of the easiest is the silver slide. Old Jack knows there are many videos out there on the net about making and using a silver slide, but I'm hoping I can give you the complete story about how the silver slides work and how and why they don't work. If the schools have done their job, oh yeah, right. We are all familiar with ferromagnetism, magnets being attracted to iron or metals containing iron. Fun with magnets in the 3rd grade, if you remember that, the iron filings and so forth. Some elements other than iron also exhibit ferromagnetism. But there are 2 other kinds of magnetism. There's paramagnetism and diamagnetism. Paramagnetism is where certain elements exhibit weak attraction to both poles of a very strong magnet. And diamagnetism is where both poles of the magnet very weakly repel the element. An interesting fact about gold and silver is that both metals are diamagnetic, silver being more so than gold. Now here on the table I have a series of elements, some attracted by a magnet and some not. Now these samples come from a great company called Metalloom. It's very difficult to find pure samples of many of the elements, and Metalloom has many of them. Even though an element may not be ferromagnetic, it may be diamagnetic. Now we're going to go down the line and check for ferromagnetism first with a very powerful N52 neodymium magnet, and I hope I am saying that correctly. Using a magnet is really the very first test you can use to find out whether what you're thinking about buying is gold or silver. Although not often done, iron and steel have been used to counterfeit coins and bars, especially older coins. Iron is heavy like gold and takes a plating very easily, easy to stamp and mold, and it's pretty convincing when covered with a thin layer of gold or silver. If a magnet is attracted to a coin, it is not gold and silver. That's a big duh. Gold and silver are not magnetic in the common sense. Now, here we have a series of elements. Here's lead, that's the first one. It's inside of an airtight container because lead oxidizes, but with this magnet being so strong, it makes no difference. Nothing on lead. Nothing on molybdenum. Nickel silver, used in the 19th, early 20th century as a replacement for the real thing in silverware, teaware, that kind of thing. Pewter, we all know what pewter is. It's mostly tin, not magnetic. Wood's metal, it's a very low melting point. It's used to make metal molds and castings. Nickel, whoa, look at nickel here. Well, nickel is obviously ferromagnetic, so we're going to set it aside. How about brass? Nothing. Coinage bronze, things that pennies are made of, nothing. Iron. We know iron is ferromagnetic. So let's go ahead and set it aside. And that's phosphor bronze, which is used to statues, that kind of thing. Aluminum. Nobody ever really makes a fake out of aluminum. It's way too light, not magnetic at all. Here's silver, 99 pure silver, and here's a 1/10 of an ounce Mexican gold coin, and neither one of these are ferromagnetic. Zinc, nothing going on with zinc. Cobalt, look at cobalt, very strong magnetic reaction. Cobalt is also ferromagnetic, so I'm going to set it aside. Now we have titanium, nothing, and tin, but there's one metal, tungsten, that we don't have a sample of, and it has been used to counterfeit gold bars. They've drilled the center out of a gold bar and slipped tungsten rods in it and then sealed the ends. It's very effective because tungsten almost has the same weight as gold. And there's some theory out there that gold coins, or counterfeit gold coins, are being made of tungsten and then plated with a layer of gold. They would be exactly the same size and thickness, but they would weigh almost exactly the same as a gold coin. Very difficult to detect. But tungsten is very hard and brittle. It is almost impossible to stamp. Now Metalloom has been trying to make one of these tokens in tungsten, but they haven't quite yet got the process down where they can actually stamp the element's name on the coin. And they're very good with working with metals and all of the elements. So if they can't do it, I'm questioning whether the counterfeiters have been able to do it. But it's something to keep in mind. Tungsten is almost the same weight as gold. Would make a great fake if it wasn't so hard. So I'm going to stop here now. I'm going to set the silver slide up, and we're going to see how these coins perform on the slide to see whether they're diamagnetic. Well, here's the silver slide that I made. When building the slide, the magnets want to position themselves naturally north to south, and so forth. It's almost impossible with such strong magnets to position them with all the same pole up. It doesn't make any difference really. It's a diamagnetic test, so it's going to repel both poles equally. Now I put them on with a little Gorilla Glue to hold them in place, but you really don't have to do a whole lot. Now, of course, you could purchase this on eBay. They are for sale on eBay, but gee, it kind of takes all the fun out of it. Okay, well, let's see how this silver slide works. I will slide the element samples down the slide to see if any of them are diamagnetic. If they are diamagnetic, magnetic forces will slow their descent. If not, they will quickly shoot to the bottom. So let's start with some samples I know aren't diamagnetic. For instance, here's titanium. I'm going to put my hand down here and I'll watch it slide quickly down. Boom, just like that. Just slides down normally. Well, let's try another one. Let's try zinc. Whoa, now see the difference? How slow zinc goes down. That indicates zinc is diamagnetic, or at least partially so. Let's try lead. Look at it shoot down. Part of it's really very slick because of the capsule, but it obviously isn't diamagnetic. Here's Wood's metal. Nothing. Wood's metal is made of lead and tin and cadmium and bismuth. Here's nickel. Nickel silver. This is the silver substitute. Boom. No, nothing. Not diamagnetic at all. Shoots right down. Here's phosphor bronze. Well, maybe it's a little bit. It's just a little slow. Okay, maybe not. Here's tin. Wow, tin. Look at that. It seems to have a slight slowing down. So we're going to say that's partially or slightly. And pewter, sled, nothing, just shoots down. Oh, I'm sorry, pewter's tin. Okay, coinage bronze, like a penny. Whoa, look at that, very diamagnetic. So this is mostly copper. A little bit of tin, which we tried before, which was slightly diamagnetic, and zinc. Here's molybdenum, nothing. Here's aluminum. Wow, diamagnetic for sure. It's very light, so it wouldn't shoot down, just doesn't have the weight to make it go down very quickly. Now, here's the proof in the pudding. Let's try a little bit of silver. A lot like the aluminum, except silver is much heavier, very diamagnetic. And of course, here's gold. It's slightly diamagnetic. Yes, okay. Here's brass. Maybe a little bit. Maybe slightly. Brass is made of copper and zinc. Okay, let's see what we've got here. Aluminum, coin bronze, copper, silver are diamagnetic, very strongly so. Whereas zinc, gold, brass, and tin are very slightly diamagnetic. Now the problem you have with the slide test is that it's a visual test. There's nothing exact about it. Whether it goes down quickly or slowly is a matter of your opinion. So perhaps we need a more sure test.